welcome back. So what we're looking at today is 5.7, get to the point. So let's go ahead and jump right in. All right, so what we're looking at here is this first part is the Pythagorean theorem. So an easy way to check if a triangle contains a 90-degree angle, also called a right angle or right triangle, is to use the Pythagorean theorem. You may remember the theorem is a squared plus b squared equals c squared, where c is the length of the longest side, the hypotenuse, and a and b are the lengths of the two shorter sides. Identify which lengths make a right triangle. So they give you an example here. We've got 5, 12, 13. The biggest side is always going to be our c squared, so it's 13 squared. So we have 25 plus 144, because that's 5, and 12 squared equals 169. 25 plus 144 equals 69. So because they equal each other, it's a right triangle. If they don't equal one another, then it's not a right triangle. All right, so we're going to do numbers 1 and 3 together. And I'm going to come up here so I have some more space. So we're going to have 9. Whoops, that's not what I want. We're going to have 9 squared plus 40 squared equals 41 squared. So 9 squared is 81 plus 40 squared is 1600 equals 41 squared, which is 1681. We add the 81 and the 1600, we get 1681 equals 1681. So are they equal? Is it a right triangle? Yes, it is. All right, the next one we're looking at is number 3. So for this one, we have 6 squared plus 7 squared equals 8 squared. 6 squared is 36, 7 squared is 49, and 8 squared is 64. So now we add the 36 and the 49 together, and we get 85 equals 64. Is that true? No. So, is this a right triangle? No, it's not. So that's what you guys are looking at doing there on that section. You're just going to square all those values, add the two smallest ones together, and see if it equals the third one. Okay? All right, moving on to systems of equations. We're going to solve these using substitution. So systems is your key word for this lesson, systems. All right, so the one we're going to take a look at is number 11 down here. So notice on 9 and 10, it tells you what to start with. So that's why I'm not going to do those with you. So on number 11, we have x equals 9 plus 2y, and 3x plus 5y equals 20. Now, I believe in your books, the plus sign has been altered to a minus sign. Mine and yours don't necessarily match up perfect. So we're going to change that to a minus sign right here. So hopefully that's the way it is in your books. If it's not, just do it as though it is subtraction. Last year's students told me it was, so I'm hoping that it's still this year. So we're going to take the 9 minus 2y and we're going to plug it in place of the x. So we're going to have 3 times 9 minus 2y plus 5y equals 20. So 3 times 9 is 27. 3 times 2 is 6 plus 5 equals 20. Now we subtract the 27. So we have negative 6y plus 5y equals 20 minus 27 is negative 7. Negative 6 plus 5 is going to give us a negative 1y equals negative 7. We can never have our variable be negative for our solution, so we divide by negative 1, so y is 7. So now that we know what y is, we can come back over here to our x equals 9 minus 2y and find out what x is. So x equals 9 minus 2 times 7. 2 times 7 is 14, so we have 9 minus 14. And 9 minus 14 is negative 5. So our solution is negative 5, 7. Remember, we write solutions to systems of equations as an ordered pair. So make sure you write them as an ordered pair, okay? X first, then Y. All right, you've got a few more of those over here. And then the next section, solving one variable inequalities. So solve the following inequalities, write the solution set in interval notation, and graph the solution set on a number line. So we are going to take a look at number 16, and I'm going to come up here and use some of the space. So first thing we have to do is take and solve this. So we have 4x plus 10 is less than 2x plus 14. And remember, this is number 16, not number 15. So we subtract the 2x. That will cancel. We'll have 2x plus 10 is less than 14. Subtract 10. 2x is less than 14 minus 10 is 4 divided by 2. So x is less than 2. So we need to find the solution, but we also have to write it in interval notation. So what that means is if x is less than 2, that means we can go all the way to negative infinity and still have a solution. So our interval is from negative infinity to 2. So it's just showing whether we can go to negative infinity or to positive infinity with our solution. So now we need to take and graph it on the number line. So we go to where 2 is. We're going to put an open circle because remember, without the equal to sign, it has to be an open circle. And then we're drawing the arrow to the left because it's to negative infinity. All right, the next section, so same sort of idea. We're still solving inequalities, but now we're going to put the solution in set builder notation. So x is an element of the real number system when x is less than 2. So that's what we're looking at. That's an example that would go with what we just had for 16. So we're going to take a look at number 20 because obviously there's some fractions going on here. So what we want to take and do is we need to get rid of the 3 in the denominator. We also need to get rid of the negative. So I'm going to multiply both sides by negative 3. So that cancels there. So we're left with x is less than, remember, when you multiply or divide by a negative number, it flips the sign. Now, because I'm multiplying by negative 3, there's different ways we could do this. We could have 30 over 9. You actually multiply it, then reduce. Or 9 and 3 are divisible. So we cancel out the 3 with the 9, and that becomes 3. So then our answer is just 10 thirds. This would also reduce down to 10 thirds. So either way, you're going to get 10 thirds for an answer. So now we use our set builder notation. X is an element of the real number system when x is less than 10 thirds. And there's your answer. So that's what you guys are doing for these. So solve them first and then put them into their notations it wants. So 16 through 19, it's interval notation. 20 through 25, it's set builder notation. All right. If you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.